All right, we're going to talk about matrices today. And matrices are kind of like giant, they're going to look like brackets, and they are brackets. So in our notes right now, we're going to take some vocab. All right, so a matrices, we say, is a rectangular array of data in rows and columns. Okay, rows and columns are going to be very important. If you're still gluing, make sure you stop and start writing. We can glue later. So, matrices are made up of what we call elements, and elements are the individual numbers in the matrix. Okay. When we talk about matrices, we're going to define them by rows and columns. Rows are the horizontal elements. And remember, horizontal goes left to right. Horizon, remember the sun sets over the horizon, so it goes down. Okay. Columns are the vertical elements. Vertical goes up and down. If you ever had like vertical blinds, my mom has blinds in front, well, she used to, in front of her sliding glass door at her house. And then the dog ran through them and broke them. So now she has a curtain. Okay. Yeah.
Oh, actually, my dog did the same thing. We have our screen, which I wasn't sure if it was my dog or something. I use this as a dog door. He just goes on our screen.
Yeah. Goes right there. All right. And then what we talk about is, lastly, is we're going to talk about the dimensions. The dimensions identifies the matrix by the number of rows and columns with rows stated first. So I like to remember it as like RC, rows, columns. RC, car, remote control, something along those lines. So it's always rows and columns. I wish it was the other way, because then I could say it's alphabetical, but it's not. Okay, so here we are. Everybody good with my notes? And then I just need a few more minutes. Okay, so here we are with our examples. So I'm sure you all have done this a million times with a friend. You sit there after school and you make a table of your science quizzes. Mm-hmm. Yeah, thank you, Will. I know you're. So we're going to organize this data. His matrix can also be like any line graph, histogram, scatter line, any kind of graph. It's another form. So we're going to analyze Sue and Eva, sorry, their grades. They're A, B, and C's. Did they get any other grades?
No.
No. All right. Now matrices have these brackets. Okay? And then we're going to we'll do Sue first, and then Eva. So we're just going to, so I have 2 rows, Sue and Eva, and I have 3 columns. Okay? Can you guys count up how many A's our friend Sue has? Right?
4.
She's got 4. How many B's? Max, D, sorry? 5. How many C's does she have? 3. All right. Eva, how many does she have? Miss Madison, how many A's? 5. How many B's does she have, Ian? 6. And how many C's does she have? Max B?
1.
Okay. So we can analyze this data. This makes way more sense if I wanted to figure out how many of each I have. What type of student could we say Sue is about? Average, right? She's not crushing it in the A department. She's holding her own to B's. Yeah, C's, maybe she needs a little bit more effort. What about Eva? What do you think? Pretty good student, right? I mean, this C, everybody has an outlier. What's an outlier? What does that mean? L?
The one piece that is like
Outside, yeah. All right, so she's got an outlier. So we're going to say the dimensions. We have 2 rows, so it's going to be a 2 by 3. Okay. All right, so now when we talk about our elements, we're going to talk about element. So we're going to write a big X, and then you do a small a parentheses B. A stands for the row. B stands for the column. The X just stands for the word element. I don't know why no one called me and asked me to pick a letter. I would have picked D, but E for element. Okay, so here remember row, column. So for this one we're going to do row 1, column 2. So row 1, column 2 is going to be 3. Okay. The next one tells us to do row 2, column 4. So I'm going to go to row 2 and count over 1, 2, 3, 4, and I get 11. Now we're going to go backwards. We want to explain the point for -5. -5 is over here, so I'm going to draw a really big X and set up my parentheses. What row is -5 in, Ryan? 3. What column is -5 in, L? 4. Okay. So we want to look for 7 now. What row is 7 in? 3. And it's in the first column. All right. Oh, let me zoom in a little bit so I can have both on the screen. All right, who can tell me row 3, column 2? Bobby, what number is row 3, column 2? Row 3, which ones are rows? Horizontal. So which is the third row? Which number starts the third row? 5, -2, or 7? 7. And now I need to go to column 2. 9. Very good. All right. Next one, Bobby, we need to do row 1, column 3. So what do you think that one's going to be? 1. Very good. Row 1 over 3. All right, now make sure, guys, I saw a lot of people with X's the same size as their parentheses. Has to be a really big X. -2 is right here. Will, what's name is that going to be?
2, 1.
2, 1. I'm in row 2, the first location. -8. Leo?
Wait, no, I just have a question.
Okay.
So what do you do if like
Get for 10.
I got X and then 2 by 2.
Just 2, 2. Good. All right, so the dimensions, remember we do by rows and columns. So Ian?
3, 4.
3. A 3 by 4. Okay. What? Oh, okay.
10,000?
All right. Everybody good with that? All right, we're going to move on to the wonderful world of adding. Okay. So in adding, matrices must have the same dimensions in order to add or subtract them. Without them, you can't find the answer. So to simply add or subtract the corresponding numbers, or really elements. Okay? Corresponding means same spot, different location. Ella and Max are sitting in corresponding seats. They're both to the left of their group of 2. Okay? So we're going to show our work. All right, so B, I'm going to rewrite it. It tells me you have negative 12, negative 5, 16, 9, negative 1, 2. Plus, and then I have D, so it's going to be negative 14. Do you guys see where I'm finding these numbers?
Yes.
They're up in the top, not just randomly making them up. Okay. So writing them out when it's like this kind of helps out a lot, especially when we do subtraction. Okay. Your homework, they're already written out, so you don't have to rewrite them.
Yes.
Okay. So negative 12 is 1, 1, right? The element 1, 1. What's element 1, 1 over on this guy? Negative 14. So what's negative 12 plus negative 14? Negative 26. Yep. Well, there's not the final answer. 9 plus 0 is 9. Negative 5 plus 1? Negative 4. Negative 1 plus negative 5? Negative 6. 16 plus 10? 26. 2 plus 9? 11. Now, Dylan, that's my final answer. That's it? Okay. Your new matrices should be the exact same size. So if you're like, ooh, I got a different row or I have a different column, okay, you just add them same spots, same element to same element. Questions? All right, subtracting wise, we're going to do the same strategy. I'm going to rewrite. Minus. We do keep, change, change when we subtract, right? So to make my life easier, I'm going to do that for every problem. I'm going to change this subtraction to addition, and then I'm going to do the opposite of all my signs. Opposite of 7 is? Opposite of 19 would be negative 19. Negative 4, that would make it positive 6. Positive 1 and positive 2. Then I can go back and just add. Yes, Dylan?
Oh, do we have to like write that?
Yes, write it out. Then you're going to be guaranteed to get it. Yes.
Do you do it on the other one?
No, keep, change, change. Keep, change, change. Don't change all of them. It's not change, change, change. What's negative 12 plus negative 7? What did you get?
19.
Yeah. 9 plus negative 19 would be negative 10. Negative 5 plus negative 4, negative 9. Negative 1 plus 6 would be 5. 16 plus 1 is 17. 2 plus 2 is 4. Okay. So C, if I look here and I start looking, and I'm going to write it out. Adding them. Are they the same dimensions? So we're going to say there's no solution. So no solution. They have to be the same size. No solution because different dimensions. Okay. Multiplying, we are going to take more matrix to be multiplied by a scalar, any real number, by just multiplying this scalar to each separate element. Whenever you think of the word scale in math, like a scale drawing, a scale toy, it's multiplying by a factor. Okay? So here we're going to take 4, and I'm going to multiply it to C. So which is 1, 13, negative 4, 2, negative 8, and 7. So 4 gets multiplied to everybody. 4 times 1 is 4. 4 times 13, 52. 4 times negative 4, negative 16. 4 times 2 is 8, negative 32, and 28. Can you guys try 17 by yourself?